Okay, everybody, I promise this will be the last video, okay? What I'm going to do now is we're going to see that there's going to be, I'm going to re-say what they say here. There's going to be more than one thing in the parentheses. There's going to be more than one thing in the parentheses. I'm just going to teach you myself how to do that. I think it's going to be easier than what you see written up there. Okay? So just trust me, unless you want to read those boxes and try to make sense out of them. Trust me that I'm going to try my best to help you out here, okay? Which expression can represent the area of this square? Well, you guys need to know that area is length times width, right? Well, they're giving us the length and the width. So area is, since it's a square, 5x cubed times 5x cubed. In other words, 5x cubed twice, so 5x cubed is a quantity squared. Because this other side here would also be, sorry, there you go. This side would also be 5x cubed since it's a square. So I'm just doing length times width. In other words, I'm doing it twice. Now watch how this works. The 2 gets distributed in. It goes to the 5 and to the x. So this becomes 5 squared x to the, are you going to say 5 or 6? X to the 5th or the 6th? When it looks like this, you multiply them. Remember, that's your rules from 7.3 that we just learned. Okay, so 5 squared is 25. And 5 squared is 25. And you have x to the 6th. So find the proper answer. Letter D. Let's try this again in the got it. I would suggest probably watching me do the got it instead of trying them on your own. The 3 goes to the 7 and to the m to the 9th. So I get 7 to the 3rd, m to the 9 times 3, 27. Please don't put 12 there. 7 to the 3rd is 243, not 21. It's 7 times 7 times 7, not 7 plus 7 plus 7. M to the 27th. That one wasn't too bad. Let's do part B. The negative 4 goes to the 2, and the negative 4 goes to the z. Okay, so I get 2 to the negative 4, z to the negative 4. But I always try my best to fix negative exponents before I do anything. They both scoot to the bottom and now have positive exponents. Remember, that's from 7.1. Last step, 2 to the 4th is 16, and z to the 4th is just z to the 4th. Okay, last one. The negative 2 goes into both of these. It goes to the 3 and to the g. I'm trying to, let me see if I can get rid of all those shadows. I know that's hard to see like that. There you go. So I get 3 to the negative 2 and g to the negative 8, because 4 times negative 2. Essentially you are, 3 has a 1, right? I hope you know that 3 has a 1. So essentially you are doing 1 times negative 2, which is how that's a negative 2 there. Neither of these are happy where they are, so you have to move them to the opposite side of the fraction to make them positive. That becomes 1 over 9 g to the 8th. Okay, I hope you're doing well with these rules. We only have to think one more page. 2 more pages, just teasing. Okay, long video, huh? Problem 4, simplifying them with products. Now look what I wrote up there. Remember to take care of the outside exponent first. We can do this. We just have a lot going on at once, okay? I'll zoom in to try to focus on the area that we're at. You ready? The 10 gets put in with the n. 1/2 times 10 is n to the 5th. Now, the 3 gets put in with the 4. Please don't think that's going to be 12. It's going to be 4 to the 3rd power. The 3 gets put in with the m. And the 3 gets put in with the n. The n has an exponent of negative 2 over 3. You might want to make yourself a note. I'm going to have to multiply. Negative 2 over 3 times 3 is a negative 2. Okay, so you put it in like you're distributing. Now you apply your rules from 7.2. and we got to put those things together. See how they're written separately? When they're written separately like this, you have to add their exponents. So we have 4 to the third, m to the third, n to the third now, because 5 and negative 2. Last step, 4 times 4 times 4, 64. M to the third, n to the third. Lots of fun on these, right guys? Okay, let's try got it. Again, I would probably watch the video here instead of trying it on your own. The 2 goes into the x, so it goes to the x's exponent, and you get x to the negative 4 here when you multiply. The 4 goes to the 3, to the x, into the y, but y has a 5. So you get 3 to the 4th, x to the 4th, y to the 20th. You multiply, you do not add. Hey, look what happens to your x's. They cancel each other out. 3 to the 4th is 81, and y to the 20th to finish. Let's try part B. The 4 goes to the 3. A lot of people miss putting it with the coefficient. They only put it with the c, the 5 over 2. So I get 3 to the 4th, c to the, well, down here I'm going to figure out what it's going to be. It's going to be 5 over 2 times that 4. So let's see, 5 over 2 times 4 is 10. So that's c to the 10. And then this 3 goes to that c squared. So I get c to the 6th, not c to the 5th. Well, 3 to the 4th is 81 again, and that's 10 and 6. You add here, when they're written separately, you add them. Final answer. One more. The 3 goes to the 6th, the a to the b. 6 to the 3rd, a to the 3rd, b to the 3rd. The 2 goes to the 5 and to the a. So 5 to the 2nd and a to the negative 6, because you multiply. Okay, let's see here. 6 to the 3rd is 216, because 6 times 6 times 6. 5 squared is 25. I'll end up multiplying those at the end. A to the 3rd and a to the negative 6 makes a to the negative 3 when you add. And you have b to the 3rd, just kind of chilling out. Well, 216 times 25 makes 5,460. Did that in my head. I'm just joking. I have the answer key. B to the 3rd, and at least I think I'm funny. A to the 3rd needs to go to the bottom because you're not allowed to have negative exponents. Yay, you never thought you would see it. The last page. It's finally here. Some more scientific notation fun for us. Okay, raising a number in scientific notation to a power, and that's what all 7 through is about, is a power to a power. Okay, here we go. The expression 1/2 mass times velocity squared, that's what mv squared means, gives the kinetic energy, that's the energy of movement, in joules, of an object with a mass of m, kilograms, traveling at a speed of v, meters per second. Yeah, in physics we tend to use meters instead of feet, okay? But you'll talk to Mr. Ledbetter more about that. What is the kinetic energy? Like how much movement, how much energy and movement of an experimental unmanned jet, that sounds safe, that has a mass of 1.3 times 10 to the 3rd kilogram that's traveling at a speed of 3.1 times 10 to the meter per second. By the way, that's really super duper fast, okay? It's 1, 2, 3. That's going to be like 3,000 meters a second. Kind of crazy. All right? Let's see how much kinetic energy that unmanned jet has. And I would draw a picture, but my jet doesn't look like a jet, so we're not even going to bother. Okay? Well, this sounds like fun. They told us that the kinetic energy is 1/2 the mass times the volume, times the velocity squared. So all we have to do is plug that stuff in. 1/2 is 1/2. The mass, what did they tell us the mass was? Here it is, 1.3 times 10 to the 3rd kilograms, 1.3 times 10 to the 3rd. And what did they tell us the velocity was? The velocity is 3.1, put in parentheses, 3 0.1 times 10 to the third, but it's velocity squared, so we need a squared on that. Well, this will be fun. 1/2 travels down, 1.3 and 10 to the third travels down. They don't have an outside exponent, so there's no need to keep it in parentheses. Might want to write that down. This 2 needs to be put in with the 3.1, so I have to have 3.1 squared. And this 2 also needs to be put into this 10 to the third, so I'm going to get times 10 to the 6th. Now, we have no more outside powers, so I'm going to put my 10s together. So I have 1/2 times 1.3 times 3.1 squared times 10 to the 9th. Now I'm going to get my calculator because I have no idea what those numbers multiplied together are. 1/2 times 1.3 times 3.1 squared. Don't forget that little squared. So we'll say 6.2, let's say 6.25. We're rounding. Times 10 to the 9th. That is in proper scientific notation. I don't have to worry about changing it any further. And energy is measured in joules. That's a lot of energy, just so you know. You'll learn more about that with Mr. Ledbetter, okay? Now, we got one more. What's the kinetic energy of an aircraft that has a mass of 2.5 times 10 to the 5th kilograms, and it has a speed of 3 times 10 squared, 10 to the second meters per second. This one's going a little slower. It's only going 300 meters every second. All right, let's go ahead and see what we can do. So we have 1/2 times the mass, so 2.5 times 10 to the 5th. Isn't it weird that's usually the only time we use an x to represent times? And velocity, 3 times 10 squared, and then the equation says to square that. So let's see, it's going to be 1/2 times 2.5 times 10 to the 5th. You don't need anything special with that because it doesn't have an outside power. Times, bring the squared in, so times 3 squared, 10 to the 4th, because 2 times 2. Now we can go ahead and at least put the 10s together. 5 and 4 makes 10 to the 9th. I don't multiply them now, I add them because they're written separately. What's 1/2 times 2.5 times 3 squared? 11.25. And bummer, this one is not written in proper scientific notation, so we get the joy of fixing it. You always have to have the decimal after the first non-zero number. So this is 1.125 times 10 to the 10th. Anytime it's a positive exponent and you move to the left, you need to give it an extra exponent. And energy is measured in joules. Yes, it was a very long lesson, and yeah, we only actually talked about 2 rules, guys. We talked about 2 rules, and then we talked like when to add them and when to multiply them. And then we talked about like fraction exponents, but you just get to use your calculator in them. So here's the main ideas, but remember, you have to do a lot with these main ideas. If you have x squared and x to the 7th, and they're written separately like this, this is from section 7.2. That makes x to the 9th because you add them. When they're written separately, you add them. When we brought you to 7.3, if you had x squared and that was raised to the 7th power, that means you would have x squared 7 times, so x squared, x squared, x squared, x squared, x squared, x squared, I don't know, I lost count. That would give you x to the 14th. So in that kind of problem, you multiply. Look at the different setup, okay? The only other thing we learned about was in 7.2, and it was fractional exponents, and it would be something like this. 16 to the 1/4, and honestly, I would have you put that in your calculator, and you would just get a 2. Remember in your calculator to use parentheses, okay? Other than that, those are the main ideas, but as you can tell, we did a lot of stuff with those main ideas. Have a good night. You're finally all done.